Aloha and welcome to this WOD, which is the writing test cases for the Project Euler Problem 1. Of course, you've done that program already, hopefully, in the coding module, and now we're going to write some test cases for it. So let's just get right into it. Following the directions, we're going to start the timer. So wait, I had my timer going. Let me start again. And then I'm going to create a branch of the Project Euler One repo called test try one. So I'm going to use the GitHub app for this because it's a little simpler. Here I am in Project Euler One. I'm under the branches tab, and I can click plus here to create a new branch off master called tests try one. And the reason why I'm calling it try one is because in these WODs, if you can't do it quickly enough, you want to actually be able to try multiple times. So we're going to create each of our tries in a separate branch. So the second time you might do this, you might call it test-try2. Okay, so now we've got this branch called tests try one. And let's see what we do next. We want to bring up the code, of course, and refactor it to allow us to test the algorithm by calling a method. Okay, so this is, if we bring up IntelliJ IDEA, hopefully in less than 10 seconds, and then we bring up this Project Euler One project, what you're going to see is that the way it's done right now initially is not too amenable to testing because there's no method that we can call. There's this main method, but in fact, the main method doesn't allow us to, for example, configure the maximum value that we want to test. And that would be a good way to kind of figure out if our algorithm works right, is that we could test on a small number where we could manually find what the expected output should be. Okay, so the first thing we want to do is convert the guts of the algorithm into a method that we can actually invoke, that's going to return a value that we can invoke as part of a test class. Okay, so it turns out that IntelliJ has this crazy extraction thing. I won't do it from the command line. I'll show you what it is. We'll say extract, and we're going to extract a method. Okay? And we're going to make this a public method because we're going to call it from a test class, which is located in another package or another place. And so we're going to call this, what should we call this? Let's call it compute sum of multiples, I guess. What the heck? Okay, so we'll say okay. And all of a sudden you can see this is cool. So we invoke this call here, but we need to make some changes. We want it to actually return the value that we want to print out. And so let me just undo this, okay? Because I realize now that what I really want to do is not that system.out.println, but just this portion of it. So if we now refactor this method, public, compute sum of multiples. Okay, this is better because it's going to return an int. Okay, now you can see that we're going to get this return value from this method, which is an integer, which is the sum of the multiples, and then we're going to print that out. So that looks better. And then the only other problem is that we'd like to pass in this upper bound value to this method in order to allow us to test different upper bounds, right? And so there's a cool way you can do that. You can select this parameter, and then we can say extract parameter. Okay, and let's call this like upper bound. Okay, and now you can see, so this is kind of cool, right? So now the IntelliJ has called this method with that 1000, which was our original amount, and that gets passed into this as the upper bound value, and then we do this. And so now we have this convenient method, compute sum of multiples, which takes a value and then returns the sum of the multiples of 3 and 5 up to, but not including that particular upper bound. Okay, so that's pretty cool. I like that. And What are we supposed to do? Now we have to create a test class containing at least 2 tests of our algorithm. Okay, so we go back here, and the first thing we've got to do is we've got to create a new directory called tests, and then we've got to mark that directory as being a test sources root. Okay, so once we have that, that's pretty important. Then we can do our fancy Command-Shift-T to create a new test. And we want to tell it that it should be a JUnit 4. And we get this little thing, JUnit 4 library not found in the module. We want it to fix it, so it basically updates our build dependencies so that JUnit 4 will be found. And then we just want to test this compute sum of multiples method. So we'll say OK. And sure, we'll add it to Git. And now what we find is it's done an import, and we've got our little test case all set up here, ready for us to actually do some tests. So let's make a test. So we can say assert equals, and then we're going to start with a string. So let's test multiples below 10. Okay, so then the expected value is going to be 3 plus 5 plus 6 plus 9. So what's 3 plus 5 is 8, plus 6 is 14, plus 9 is 23. Okay, I think that's right. And then what we're going to do is we're going to call the expected is going to be 23. The actual is we're going to call our project Euler One dot compute sum of multiples, and the upper bound is 10, right? 369 is 18 plus 5 is 23. Okay. So there's our test class. So let's run that to see if that worked. So we've got to go run project Euler One test. Okay, and the test passed. Sweet. Okay, so let's make one more test case, which would be the ones below 20. So I'll do a propeller D to just make a duplicate of that line. And then I'll go 20, and then 20, and then what the heck is the multiples up to 20? Let's just do that by hand. So 3 plus 5 plus 6 plus 9 plus 10 plus 12 plus 15 plus 18 equals 78. Okay, so we're going to hope that my calculation is correct, and then we'll say run project Euler One test, and it's cool. Okay, so we've got our 2 tests. Let's go back to this. So we ran our test case, we fixed problems until it passed. It turned out we were good. It passed the first time. Now we want to enable check style on sources and tests and remove all coding standard violations. Okay, so let's go back and let's do a propeller semicolon to see if we have check style enabled, which it does not appear that we do. So let's go back to preferences, other settings, check style, and unfortunately, we don't have the rules. I don't know why this thing keeps losing it. I'm going to have to really work on that. What I'm going to do is use a check style file accessible via FTP. Okay, and to do that, I'm going to go here, and then I'm going to go modules, coding standards, install check style IntelliJ, checkstyle.xml. Here's the URL, And then I'm going to put it in here. Oops. And then we're going to call it ICS-SE. Next. Finish. I'm going to click this to make it the default one. I'm going to say OK. Oh, but then the other thing we got to do is in the same window, we have to scan the test classes as well, because we want both our sources and our tests to be checked. Okay, so now we say OK from that, and now we go to here, and that looks OK. So now we can do inspect code, and we'll do, I guess, the whole project. Okay, and we get 8 items. Okay, so we've done 2 of our files. The first one, the project Euler One, we don't have a package info file, so we can fix that. And then we're missing a Javadoc comment from both the main and this compute sum. So why don't we just fix that? Actually, while we're here, I don't really like this comment. So solves project Euler problem 1. That's a little more informative than just created by Johnson. And then we're going to say computes sum of multiples up to 1000 and prints out answer. The args are ignored. And then if we come down here and we say computes and returns sum of multiples below upper bound, the upper bound for summation, the sum of multiples. Okay, then we get this. Let's see what this one is. Oh, equals is not followed by white space. So that was left over from the first time I did this program. I didn't realize I did. Let's inspect the code again. Whole project. And now, oops, what I see is check style. So now we're just, we've fixed everything in Project Euler One. We've got to go to Project Euler One test. So we need a package info file in this test directory. So we can new packageinfo.java. Yes. Now, you keep wondering, why are we creating this stupid package info and just ignoring it? Later on in the semester, when we have more complicated projects, you'll see the use of the packageinfo.java file. Right now, because these are so simple, it doesn't really matter. Using the star form of import should be ignored. So it turns out that there's a nice way to fix that. We can just go to code, optimize imports, and if things are set up correctly, that will replace all the wildcards by their actual hard-coded class names. If it doesn't do that, then it's because you haven't set up IntelliJ right. Go back to the install IntelliJ in the development environments module, and it goes through that part. Okay, so we're missing some Javadoc comments, so why don't we do that? So tests the project Euler One class on small numbers, and then tests sum of multiples with 10 and 20, exception if problems occur during computation. That's unlikely. If they occur, then the test fails, which is which is fine. That's and so there's no reason to try to catch exceptions or anything in here. Okay, so let's try to inspect code again and see if we're all good. And yeah, so we've gotten rid of all our check style errors. So now that's part of the problem is done. So let's go to test project Euler. We removed all coding standard violations. We commit the branch to GitHub. So we go back to here, and we can say publish. Okay, and Now we can say added tests and fixed check style errors. And we can say commit and sync. Okay, so that's all done. And then if we view this project on GitHub, what we'll now see is that we have a master branch, which is our old one. And we also have this tests try one branch, which has this test directory, and the stuff that we've just done. Okay? So given that, it looks like we can stop our timer. And I'm going to say 15 minutes. Well, I'll say 16 minutes. What the heck? Because I did go a little bit over 15 minutes. So we'll say this is a 16-minute WOD. Okay, now let's say that you wanted to do it again. Okay? It's really simple. That's what this using these branches is so great for. So we can go back to GitHub. We can say switch to this branch. Now we're back in master. And if we go back here, okay, so IntelliJ is going to freak out a little bit because all of a sudden the file system has changed so that all our work, this Project Euler One test, that's all gone now because it's in another branch we're not looking at. So it tells us that things were changed. And we say, yes, reload project. Okay, bam, we're right back where we started at the beginning of the WOD. Isn't that awesome? Okay, so now there's this really easy way to repeat the WOD. You just create a branch before you start the WOD, and in my instructions I'm always going to have you do that. And you start off with try one, but if you do it again, you can name your new branch try two, kind of keep incrementing them. Go through it, get finished, commit it. You've still got, that old WOD if you want to go back and look at it, but you can now really easily backtrack to where you were before and move on. Now later on the semester, you're going to see we're going to start incrementally building things. In that case, what you're going to do is once you finally get the code written exactly the way you want, and you've done the increment, you take the final branch that you like the best, and you're going to merge it back into master, and that now becomes the starting point for the next kind of increment of development. Okay, so that's the way we're going to roll from here on in. So I hope you liked it. That's Test Project Euler Problem 1. See you later.